Welcome back. We're now going to look at Java error handling. We've already learned what a class is and what an object is. An object is an instance of a class. We've learned about attributes and methods. We've learned about Java statements and control flow statements. So now we need to know how to handle errors. Luckily, Java has a fairly mature error handling system called exceptions. Exceptions are short for an exceptional event, which means it should only happen rarely. Exceptions are events that occur during the execution of the program that disrupts the normal flow of the program's instructions. Exceptions in Java are objects. Remember, in Java, everything is a class. So an exception class is a class, just like an enum is a class and an interface is a class. The specific properties of an exception class is that it contains a description of the error. The code that causes the error is said to throw the exception, and the code that handles the error is said to catch the exception. So that phrase, throw and catch, are important. So what are the advantages of using exceptions? We already know from our discussion of methods that every method can return a value. And we could just encode that return value to include indications of whether it was successful or not. And in fact, early programming languages often use that method. The problem with that is you end up intermingling the code that processes the error with the program logic itself. And that intermingling makes the logic of the code much harder to read. By using exceptions, we can provide a very succinct and straightforward program execution path, the program logic, and we can have the code that processes the exception in a separate place. Another advantage of using exceptions is they propagate error reporting up the call stack. Imagine if we were using a return code to encode a message and it was 6 levels deep in a subroutine. So a method generates an error and returns it to the method that calls it. That method would have to have an if statement to check to see what the return value is, and then if it's an error, return its own error code. The method that called it would then have to have an if statement to check its return code, and if it generated an error, return back to its parent method, and so on and so forth. With exceptions, even if I'm 6 levels deep into nested methods, I can throw an exception, and the exception handler that catches the exception could be way back up in the call stack, 6 stack frames back up in the call stack. I can have the method that is actually going to handle the error properly. So exceptions use inheritance to create a hierarchical taxonomy. What does that mean? That is exactly what we just covered in the section on inheritance. We have a base class in Java called exception. Derived from that base class, we have different categories of exceptions. And derived from those category classes, we have more specific classes that actually contain individual exception causes. So we can use inheritance to create a hierarchy of these classes that groups them together and makes the handling and learning about which exceptions do what much easier. So there's 3 kinds of exceptions in Java. The first kind is a runtime exception. A runtime exception is an internal error to a program that usually cannot be recovered from. The most common of which is the null pointer exception. You also have illegal argument exception, index out of bounds exception, number format exception, and there's a couple others. Errors are external to the program that cannot be anticipated and cannot be recovered from. Examples of those include out of memory and a stack overflow. So what is a stack overflow? Remember, way back at the beginning, I said every time you call a method, you create a stack frame and push it onto the call stack. And when the method exits, you pop that stack frame off of the call stack. Well, the stack has a limited size. And remember, in our section on looping, I mentioned one of the types of looping is recursion. Recursion is when a method calls itself. Obviously, you have to check for the exit condition in that method. If you fail to do that, you can create infinite recursion, which means your method calls itself forever, which means it creates an infinite number of stack frames and pushes them onto the call stack. Eventually, the call stack is going to be exhausted and you're going to run out of memory. So that's the most common cause of a stack overflow. Another exception in Java is a checked exception. These are actually the most common exceptions. Checked exceptions are internal program errors that you can recover from. The Java compiler requires that every method that throws a checked exception has to declare it, and any method that invokes a method that can throw a checked exception has to either handle it in a catch block, or it has to declare that it too can throw that exception. So some examples of checked exceptions are file not found exception and IO exception. So these are generally things that you can recover from. So what does exception handling look like in code? Exception handling uses 3 different blocks. Remember, a block in Java is a group of statements that are wrapped in curly braces. There's the try block, there's the catch block, and then optionally you can include a finally block. The try block contains the statements that comprise the program's logic. So that's the non-exception path. That's the happy path. The catch block contains statements to execute when an exception is thrown. And you can have multiple catch blocks, one per type of exception. And remember, because of abstraction, you can actually put a catch in for a parent class and capture many different kinds of subclasses, all with one catch block. Lastly, the finally block contains code that must execute, whether an exception was thrown or not. So typically this is used for cleanup code, like closing files or closing network sockets or anything else that has a limited number. So let's look at an example of exception handling. When I say exception handling, we're talking about the catch portion of the exception. So the first thing we see is a try block. So in our code, we have the try statement, that's a reserved word in Java. Then we have a block delineated by these curly braces. Inside that block, I put my program logic. I'm declaring a local variable output value in the scope of this try block, and it's going to be initialized by invoking the getAccess method of joystick, and it's going to pass it a constant, ky member of access type, member of joystick. Remember when I spoke briefly about naming conventions, I mentioned that C++ uses a different naming convention than Java, and the FRC Java library is a cross-platform library. That means there's both a C++ and a Java version of it. So the naming conventions that we see in the FRC library tend to use the C++ naming convention. So the lowercase k simply means it's a constant. We then take that variable output value and we pass it as a parameter to the setX member of left Jaguar and the setX member of right Jaguar. So we're going to set the output of both the left and the right Jaguar motor controllers to the same value we received from that joystick. But what happens if there's an error? Suppose we get a can timeout exception. We follow the try block immediately with a catch block. This catch block has in parentheses the type of the exception it can catch along with a local variable. It almost looks like a parameter. And then we have the block of what to do when we receive a can timeout exception. So in this case, we're going to call a reset can bus member of GameMech. So how do we throw an exception? In Java, there's a reserved word, throw, which will throw an exception. So let's look at a little bit of code. I have a method called findTargetInImage that takes a color image, named image as a parameter, and it returns a target position object. That's an object reference, and it's public. The beginning of our method is this curly brace, and it extends to this close curly brace. And inside the method, the first thing I do is I check the parameters that were passed. So since color image is an object reference, it could be null. So the first thing I do is a null check. If image equals null, that's the equality operator, I'm going to throw new illegal argument exception, and I'm passing it a string. Image cannot be null. Remember, in Java, an exception is an object, and the only way to create an object is to use operator new and create one on the heap, and that returns the address of where that object is located. And that reference, the address, is what the throw statement requires as an operand. Illegal argument exception is a runtime exception, so there's no need to declare that the method throws it, because there's really nothing you can do to recover from it. Lastly, we have the finally block. Code inside the finally block is guaranteed to execute whenever the try block exits. It doesn't matter if the try block exits from a break, a continue, a return, or throwing an exception. So it's useful for cleanup code. So let's look at an example. Try, here's our block for the try block, socket.getOutputStream.write data. If is done, return. So if is done returns true, we're going to return from this method right here and skip everything that comes next, except for the finally block. The finally block is guaranteed to be called, no matter how we exit the method. We're also catching an I/O exception, and if we get one, we're going to log the error. And that too, after logging the error, guarantees to call the code in the finally block. So what does the finally block do? If socket does not equal null, socket.close. So that's a very brief introduction into exception handling in Java. One of the reasons it's so brief is because there really isn't that much exception processing in the FRC library. So in the next class, the FRC class, I'll actually go over how you use the FRC API and which methods you have to catch exceptions on. Thanks for watching.